Hello everyone, welcome to lesson 9, using Python and Blender to create this more advanced tank model. If you watched our last episode, we completed our um, our 5 animations. So if you play it, you can see the valves turning, then they're gonna turn back, and they're gonna turn back right as this water comes out, because like the workers are just looking and they see the vessel overflowing, so they turn it back, and then this turns and it goes in, the gauges go up, but then this thing goes down, this thing opens, allowing water to flow out again. Alright, so that's what's happened. However, you may notice that our last keyframe was like over here, and we still have a lot of space to do stuff. And you may think it's just so you can like watch the water flowing out, but actually we're using the last 50 keyframes here to animate something else, and that something else is gonna be the collapsement of this tank, because water is coming out of it, right? Right, water is coming out of it. But but because of physics here, there's gonna be negative pressure inside this vessel. This means it's probably gonna implode, and that's what we're going to animate, the implosion of this vessel. So let's get started. So we want to make a code in between this thing start to drain and the animation timeline part at the bottom. So let's make some space, which we did, and let's start our code. So first, let's create the code to like separate this part, like define the section. So negative pressure collapse on test vessel. We're gonna animate that using cloth simulation. So we're gonna put a modifier on our vessel to make the vessel collapse. Alright, so first let's write vessel equals test vessel, because test vessel here, it's test vessel, it is the it's what we defined in Python as like the object for test vessel. I'm just making vessel because I'm lazy. Alright, now that we've done that, we can add a cloth modifier. So cloth mod is equal to vessel, this vessel here, dot modifiers dot new. Cloth name is cloth sim, and type is cloth. actually told Python to create a class modifier on it. Now we'll do something. We're gonna define the frames for which this vessel will implode. So, point catch def start drain valve open end frame plus 63. So 63 frames after drain. I'll put 2. Let me switch there. So 63 frames after the drain valve here opens. It's gonna implode because we need the water to gush out first, so the negative pressure can build up, causing the collapsement. And now obviously we need an end frame, so copy this. Right frame end, and we just paste this again, frame start plus, and instead of valve moving frame like I did, like I almost wrote, it's gonna take up 50 frames of our animation timeline. Alright, now we can put in the keyframes after this piece of code. Cloth mod dot settings dot use pressure, set that to true. Okay, now we can actually start putting in the keyframes. Cloth mod dot settings dot uniform pressure force 0.0. So there's no force on it yet. And we're gonna put this insert this keyframe where the force is 0. At frame 1. So frame 1. Copy this, paste it, and then make it dot frame start. Alright. Oops. Let's copy this again. And this time, we get negative 30. Because obviously negative pressure, so we want this. So we want the pressure to go in when it implode, so it's negative 30. And then frame is gonna be cloth mod end. Okay. Now, actually, before I test this animation out, let's do something. Let's change the start from a 300. This way we don't have to look at the rest of the animation before this. You can already see it's a bit jiggly. Oh, it's a good sign. Alright, let's look at this. Whoa, it's jiggling. It's like jiggling, and then it was like imploding. It's like crushing itself in the middle while jiggling the sides and falling through the columns and the floor. So what happened? Do we make a mistake in our code? No. We just forgot to add some stuff, and we're gonna learn how to add them now. So let's go back here. And let's first fix the problem. Let's fix the problem of it falling through everything. And how do we do this? Well, actually, it's quite simple. Go over here, cloth mod, dot settings, high factor, weights, dot gravity. So we just turn off gravity here. We just turn off gravity completely for this for the vessel. Coming back here, we can see even without turning this into wire, you can see. Well, now it's collapsing without falling because we just turned off gravity. It, nothing's pulling it down now, so it can collapse and stuff right here. Alright. Okay. However, this collapsement, well, it's not really what we want, right? It's not very realistic. I mean, if there's gonna be negative pressure coming out of here, you don't want it to be like that. I mean, let's just change the frame to 150 and check it. So like the valves going, and then it just does that. It's checking the whole animation. I mean, you already get what I meant, but like it looks really strange to just have this kind of realistic animations of the pipes in water, but just coming out and just flowing like realistically. The gauge is turning and looks pretty good, but then the negative pressure thing comes and then the water spills out and then the tank just does that. Alright, so let's fix this. So building this thing, let's actually go to modeling. You can see that to build this thing there are actually multiple points. Let's try to build this. Let's go to mesh. Those are multiple points and they're all connected to each other in a way so to make the shape we want. And it's just jiggling like based off of these points. You see these black dots? It's just jiggling based off of these points. So you want to make sure that to make this more realistic, let's add more points across this vessel. Basically, we're just going to subdivide this middle part, like cut this into 5 pieces, so there are more points in the middle of the cylinder. So, yeah. But first, we have to go all the way back up at the top of our code, because, well, we just need to import something. So you see import BPY, math, import vector, Euler, those kinds of stuff. We're gonna add something else, bmesh and random. Random we're not gonna use, I don't think, in this lesson, but bmesh, that thing we're gonna use. We're gonna use bmesh. So you can see we have this. That's only because I'm lazy. Let's just make mesh equals vessel.data. So the vessel's data is going to be put into mesh, and then we're going to build a B mesh so we can subdivide all edges. B mesh is basically just a mesh, like build a new mesh, and then we can divide them. Mesh is just for the vessel. So bm equals b mesh dot new mesh, then bm dot from mesh. So this mesh is this mesh. So yeah, it knows that we want to build a new mesh of that mesh. So subdivide every edge into 5 cuts. Actually, let's make this 10 cuts, just so we can, I think it'll be better. So bmesh.ops.subdivide edges bm. So the new bmesh we made, edges equals bm.edges. This just means all edges, so we're modeling all of these lines. Those are the edges, so we're just gonna take all of the edges and we're gonna cut into all of these edges 10 times so we can get our new points. That its edge is cuts 10, and then use grid full is true. So I just use a grid, and then hopefully it runs. Subdivide. Oh, it's not full, it's fill. And actually, I forgot some code anyway, so that's a good thing it stopped us. bm.toMesh. So just write back to the mesh. I just make sure that this writes back all the way to the mesh. So we're doing it to our vessel, and we're just freeing it. Okay. If we go to modeling, let's make this properties viewport wire and click on this. Let's go back here and click we could just go over here, find the vessel in here, column floor. It's very slow now, so let's just give it some time. Yeah. I search for the right part in here. You can see it's slightly different now. I think it'll be better to search for it if it's very less like. Okay, I found it. It's over here, test vessel. Let's just click on that, and let's just wait for this animation to run so it's not as laggy as this, and I can show you more clearly how to do it. Alright, you can see it's different. And actually, let's just make this 300, 350. I should have done that way earlier, but it's fine. And let's go to modeling so I can see it better. And look, we cut through it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. And you can see we have made new points over here. It's causing it to jiggle better. Well, now it's not animating, but I think that's a problem. Okay, now it's doing it. Okay, I think that was just lag. So let's pause it so it doesn't lag that much anymore. And address our next issue with this. It's still not realistic. It's better, but it's still not as realistic as I would like it to be, right? So let's move on to our next part, which is pinning. We go to this animation. You can see that in real life, even though the tank is imploding, it won't make that much sense if the edges are also imploding, right? Like also jiggling, right? So we're gonna do something called pinning. And it sounds pretty straightforward. You just pin these specific points. So you just don't move at all. Alright. However, to explain the code, I'll have to do a bit of drawing. So let's open Paint. Alright. Alright. So let's say this is our cylinder. We made it like right side up because, well, if you remember that it was supposed to be this, but then we tilted it over. So the length is actually still the z-axis of this. Okay, but I'll have this open while I make the next code, and I will explain it as we're doing it. Actually, first let's make a comment. Make a vertex group for pinning. You see, we're going to make a group for pinning. So pin vertex group equals Vassal dot vertex groups dot new. I'm gonna make some space there. New name equals pin group. So we made a new vertex group. Now we're just gonna figure out which things to put in. So pinned. No, that's the code. The top and bottom rims should be fixed, which are just this ones to the very left and the very right. Those rims. It's top and bottom because the Z is tilted, so and Z is usually top and bottom. That's why. Alright, so this C is 1.2. So over here, this is the middle. So up here, at the very top and the very bottom, I should be 0.6 away from here, right? Well, that's what it would be if math wasn't complicated. Because instead of exactly being 0.6, it's like 0.5999, something very, 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 very close to 0.6. Alright, so those are the z coordinate of the top and bottom. Alright, bottom is negative 0.6, but you know, same thing. Very, very, very close to negative 0.6. So the z-axis of them are very, very close to 0.6. So, so when we're coding, we're making the code to tell it which ones to use, which parts to be fixed. For index for v in vessel dot data dot vertices if 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 the coordinate dot z is smaller than negative 0.5. So if it's smaller than negative 0.5 or dot z is bigger than 0.5. So either smaller than negative 0.5 or bigger than 0.5, which would make sense for the code. Yeah, because it would be, it's going to be very close to negative 0.5 and 0.5. So yeah, that's what, and if you run it, let's see, I don't know if there's going to be a difference. There's not a difference because we're not done. Because right now we've only made the vertex group. So we have to make sure that we want to make it so that that group of vertices don't move. Alright, it's the same because we're not finished. Alright, now we have these group of pinned vertices, but they're not like assigned to the actual vertices. So let's do that. First, so we're gonna make a variable called verts, and that's just vessel.data.vertices. And then for I, we enumerate verts. So we're making a for loop for I and then the v and enumerate verts. If I in pinned vertices, so pinned vertices over here, if the vertex is in that thing, if the vertice, because we're getting every vertice right, and if that is in pinned vertice, then w was 1.0. Else it's gonna be 0.6. W meaning its weight, the weight, and basically pin vertices dot add we're gonna add weight. We're gonna replace the edges with the ones we have right now. So basically, it's just, this is what it's doing. Alright, now I'm gonna do one more thing down here. We need to make a cloth mod dot settings dot vertex group mass pin group, and basically oops, not pin, in a type over here. And now we want the masses just to help us make pin, help us making sure that we're just telling it to pin all the points at the edges. That's what the mass thing we just wrote is. And as you can see, the edges are pinned and it's collapsing, like it's like more realistic and more believable, right? So yeah, you can see it's just imploding. Like, it's actually very similar to the point we made, to the implosion thing we did as our first model. However, we still need to make some adjustments and some changes to this. We'll do that next lesson though. That's all for today. Bye.